Hello guys! In the last Advent of Code video we were able to solve the day 1 completely and then the first part of the second day, and we left stuck in the part 2. But yeah, let's continue from here. Let's reconnect the Colab environment and let's start coding. Yes, just to familiarize what was the task or the problem for this day. We had in the first day these reports, and there was this rule based on which each report was successful or not, or safe or unsafe. And then in the second part, the problem was otherwise the same, but if there was one kind of problematic value in the report, we could deem it as safe in that case as well. So let's continue. So for the day 2, can we somehow minimize this? I think we had the same problems last time as well. But yeah, in the day, part 1, we used this simple function that checks that is the value safe or report safe or not, and then we gonna started to extend that. For now, I think I want to start from scratch. And can we actually somehow minimize this? No, I guess not. But yeah, doesn't really matter. We can have another cell. Paste the code here. We need to run this inputs. So it is in the runtime, and then we can start. So by default, let's confirm that this actually works. So 572, and that was the part 1 answer, correct answer. So how we could start tackling this? So basically, we know that if the report is safe by the current implementation, we can say that, or can count that in already. So we need to kind of re-evaluate the unsafe reports. Okay, so basically what we could do is that if report is not safe, we unsafe reports, and then we could just add the report in this. So basically it's the input. Okay, so then we should get the same value. Good. And now if we check the unsafe reports, we should have a quite nice array. Yes, good. So these are unsafe reports. To handle these, we want to create something that is similar to this, but not exactly. So what we would like to do is that we would like to have for report in unsafe report. So what I'm kind of thinking is that if we have for every unsafe report that we have, if we one by one take one value out of the report and then check if it's valid, we could maybe get some results. So basically, if we what could be? So basically, for index in len report, we can use the range. This should start from the 0, but we can specify it. Was there already correct amount? Yes. So now we should have the indexes. And then if we do this kind of similar checking, so if is report safe, and then or actually maybe let's make it a bit more readable. Modified report. Can we, because it's an array, was there a pop function? Yes. So we can use the pop with index, and then this should, let's actually do one test. So if we have an and then we do this, is it in place or not? It returns 2, okay. So is the T now modified? I'm a bit, yeah, it is modified. Okay, this is not something that we want. Specify that is it. Okay, there is nothing. Okay, then we need to do something else, because we can't modify the report, or we don't want to modify the report. I think maybe if we import copy and then we do copy. I think this should then give us let's actually test this out. Yes, and then if we do copy t pop to, this is not like the best way to do this. Yes, super. It's not the performant way to do this, but for this example, I think it's okay. So now we should be okay or good. Modified report, and then if this is true, we want to collect the values as well. So basically we want to actually we can do the same amount of safe unsafe reports. So basically of safe, just to keep the variables separate, and we need to remember to break here so that if this happens, we will break this loop so that we know that this report was fine. We can go to the next one, and then we can just print that value out. Let's actually run this. I'm interested to see what is the int object is not super. Oh, yes. Aha. Okay, yes, true. Very true, yeah. Report copy. And then we want to do this. We don't need that. Like this. So we first make the copy, then pop the index from the copy, and then check the values. 33. So basically 572 plus 33, it comes up as 605. So if we try to submit that one, our previous result of 607 was quite close. So let's see, is this correct? That's not right answer. If you are stuck, okay, that was not correct. Let's just double check that these indexes are correct. A bit. Yeah, they seem to be, so they start from. Okay, interesting. So we have amount of unsafe reports. Or actually, it's basically this. So there are 428. Am I now like missing something? One single bad level. And then if. Okay, those are looking good. So I'm kind of thinking that maybe this copying report and then report copy. I have a feeling that this might have something kind of going on. Actually, let's do it so that we will print it here. only for the successful ones, so you will have fewer one. Maybe I will actually, let's add, and then report copy. Maybe remove those prints, eases up a bit. So it looks fine. Basically, like I'm just wondering that, do we have now removing a single level from an unsafe report would make it safe. The report instead counts as safe. The problem dampener can remove a single level from unsafe. How many reports are now safe? Like I'm now wondering that are we losing some or missing some items? Something is not now adding up. And I guess there is so handling report 16. So this looks correct. And then single bad level in say otherwise be a safe report. It's like bad level never happened. Yeah, I don't know. This is a tricky one. I'm not sure exactly why this is not correct value. Or am I like just to make sure 605, so I didn't calculate it wrong. Interesting. Now I'm kind of wondering that are there some like why this equals to 1000, which is correct. Okay, let's then amount of unsafe reports, and then let's do it here. Just to kind of make sure that we are not skipping anything. Wait a moment. No, yeah, it's How can I now double check? Okay, it runs through every report, which is nice. Actually, I know now. We can do this here and then do it like this. Yeah, it's those are matching. Now I'm wondering, is there like, actually let's double check this range. Yeah, list range. Oh, from 0 to 10. Ah, okay, this was the culprit. Now we are talking. So it's 612. Yes, finally. That was a bit tricky one. Should have double checked this how this range was working. I was kinda thinking that it was counting also the last value in, but it wasn't the case. But yes, now we can proceed to level 3 or day 3. Mull it over. Our computers are having issues, so I have no idea if we have any chief historians in stock. You are welcome to check the warehouse, though, says the mildly flustered shopkeeper at the North Pole Toboggan rental shop. The historians head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? The computer appears to be trying to run a program, but its memory, your puzzle input, is corrupted. All of the instructions have been jumbled up. It seems like the goal of the program is just to multiply some numbers. It does that with instructions like that, okay, where x and u are each 1 to 3 digit numbers. For instance, this multiplies 44 by 46 to get the result of 2024 or 2024. Similarly, would multiply to, yes, okay. However, because of the program memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of multiply instruction. Sequence like this and this, or this do nothing. Okay, so their spaces are also like. For example, consider the following section of corrupted memory. Only the 4 highlighted sections are real null instructions. Okay. Adding up the result of each instruction produces. Okay. Scan the corrupted memory for uncorrupted null instructions. What do you get if you add up all the results of the multiplications? Okay. How our puzzle input looks like. Okay. Yeah, so let's start by copying this. I think we can delete this one and then day 3 part 1 and then input, and since this I guess is multi-line. No, it actually was not completely. I think we could do, actually, I guess we can do it like this. So the kind of the initial idea or approach that comes to my mind immediately is to use regex for this, and I think it could be the way, because otherwise we need to loop through this whole string and then figure out how to parse these. Yeah, we would need to loop this through or use regex. Maybe we could start with the regex. What kind of pattern we would actually need? We could check some regex generator maybe. I think this could be one. Test string. Okay, so we definitely need the mul, and then like this. Then we need to specify the digits. Oops. D. Is it like this? No. Oh, maybe it's these curly things actually. Yes, good. Then comma, it's just like that, and then we just repeat this. Repeat this section, and then if we want to, okay, that seems relatively okay. So if I take a couple of is there some like unmatching as well? Let's try to find. Oh, there is one. Let's add that here. Okay, does not match. That's good. And then if we just make something like this, and then one. Okay. Let's use this pattern. I don't know why it feels a bit laggy, this Colab today, but I think this should be it. And then input is just input, yeah. Red dot, I think find all, yeah. And then it wants the pattern. Send first and then input. What if we run this? I'm now wondering that is this something that, or maybe that, let's try now. Okay. Okay, this looks good already. Very good. Okay. Then 8 minutes, and we can just. So what was the so we want to adding up the results of each instructions. So we need to multiply those. Okay, cool. Total is 0, so for statement in mul statements, let's loop those through, and how we can get those digits out. We can just, this is a bit hacky, but since we know that there is kind of two values, first and second, we can do, and no kind of third ones, we can do that statement replace mul opening parenthesis. Let's replace these with empty strings, and then we want to replace the closing parenthesis as well, and then we want to split from the comma. So now if we do total plus equals, so it was multiplication, so we can just do integer first times integer second, and I think we should be good. Maybe we want to print the total. Seems slightly high, but let's try. Okay, it was correct. Cool. Then the part 2. As you scan through the corrupted memory, you notice that some of the condition statements are also still intact. If you had some of the uncorrupted conditional statements in the program, you might be also get a more accurate result. Okay, so it wasn't accurate. There are 2 new instructions you will need to handle. Okay, the do instruction enables future mul instructions. The don't instruction disables future mul instructions. Okay. Only the most recent do or don't applies. At the beginning of the program, mul instructions are enabled. Okay, so basically what we would like to do, since this, let's actually add day 3 part 2. Okay, I think we can kind of utilize this similar logic, I think. Since basically since we know that mul statements, let's print those out. They are in the order that they are found from the input. So if we extend our regex so that it would catch also these do's and don'ts, then we should be good. So, how can we do that? So basically, if we would have, let's say, do statement here and then don't. Was it this pipe operand that, not that one, this, okay. So if we have then do, okay, can you actually make it happen like this? Not like that. Okay, now it gets that one, okay. And then if we do just, do we need to escape that one? No. Or how that character is even, because we need to escape these. I have a typo. Okay. So if we basically do these things in our improved, we can actually just copy these. Oops. Copy these to here. And now we should see. Yes. So basically, we can utilize the same logic, I think. Yes, total, yes. But now we need to multiplication enabled. True. Sorry, yes. So if statement is do, then we do multiplication enable true, so we will enable that one. Elif statement equals don't, we will set the multiplication enabled to be false. And then if this is the case, then we will continue. Continue is important so that we won't break the rest of the logic. And then actually we need to also then check if multiplication is not enabled. And if it's not enabled, we want to continue. So we will skip the values. And then we will total the values up and or sum them up, and let's run it. So we got quite a much lower score. Yes, cool. We finished the day three actually quite well. But yeah, I think this video has gotten quite long already, so maybe it's good to pause here, and let's continue in the next episode. But yeah, thank you for watching, and see you guys next time. See ya!